Hello guys, we're Team 4. This is our overall organization of presentation. In our proposal step, we introduced the paper Lipstick on a Pig. I think you guys might have forgotten about what was the topic of this paper. Shortly, language models are trained from corpus reflecting of a lot of social biases, so the models also contain it. Before this paper, bias mitigation methods were proposed. However, the proposed methods applied on the words fag and glove were not effective. The paper conducted 5 experiments, which was number 1, number 3, and number 5. Most of the resources and codes are accessible. We installed and imported those original and biased embeddings and render codes. Updated version of libraries, we corrected several things. Our first experiment is visualizing clusters of gender-biased words. We selected 1,000 almost biased words by computing direct bias using cosine similarity and utilized TSNE for projection and quantify degrees with K-means algorithm for them. Second experiment is proficiency. We used proficiency list containing occupations and degree of gender bias of each. We computed indirect bias using number of male neighbors of word and compared with the original bias. We also obtained the same result of plots and Pearson correlation values. The last experiment is SVM classification. We trained SVM with biased 1,000 and tested with 4,000 words. The accuracy is not exactly the same with the paper because of the random divide for the test and training set. However, we can get same conclusion that SVM can classify the biased words even after applying mitigation methods on word embeddings. As the paper pointed out, mitigation methods achieved to reduce the direct bias, but not indirect bias. Also, through the replication, we can reproduce the same conclusion with this paper.
Now let's dive into our project progress, starting with extraction of BERT embeddings. To remind you of our first research question, it is how much bias will pure BERT embeddings contain? We chose BERT based on KAIST for our model. Since we are trying to examine the bias for the users of BERT, we believe the most widely used model to be the best starting point. To compare with our paper, Lipstick on a Pig, we first decided to keep the vocabulary pool used in the paper, but of course utilize the extracted embeddings from BERT. Here comes the first decision point. How do we deal with vocabularies not found in BERT? For instance, babysitter is tokenized into baby, sit, and turn. To examine word-level bias, we had to reconstruct embeddings from those 3 subwords into one. We referred to a paper, Subword Pooling Makes a Difference, which carried out a thorough investigation of the effect of the different reconstruction on downstream task performance. The best performing approaches were embeddings created by adding another attention or LSTM layer. However, to examine the sheer bias of BERT embeddings itself, we decided not to train another layer, but use the next best metric, adding the first and last token. Also, to preserve contextual information from other tokens as much as possible, concatenation of last 4 hidden layers has been done as presented in BERT paper. Now, let's really look into our experiments. We have retried all 3 replication experiments with BERT embeddings. This picture shows clustering of embeddings from hard device and GN Glove, with embeddings from BERT cluster 2. Surprisingly, unexpected results were obtained. Clustering with BERT embeddings actually showed a finer mixture, conflicting with the consensus that language models exhibit high bias, which was proven by many researchers. However, we found a clue from our paper to explain the results. Bias words used in the paper were chosen according to bias level, which are computed as the projection of a word to the gender direction he minus she. The top 500 male words actually look somewhat weird, containing quite a large volume of words that are irrelevant to male. Female words included lots of female names, but also displayed words that could not be seen as one of the top 500 female bias words out of 20 to 40,000 words. Next, profession experiment reveals an even more stunning picture. Most of the words demonstrate great bias towards male words. What's more, well-known examples of female-oriented words like nanny, nurse, or housekeeper show the significant male bias. Clear correlation of male neighbors is not found. Last but not least, classification of word embeddings showed promising results. SVM classifier well distinguished male and female-oriented words only from their embeddings, presenting noticeable bias in bird embeddings itself. In overall, the results of our experiments did not display equal amount of bias from original embeddings. Reflecting upon the metrics used in 3 experiments, we believe the difference between original experiments and those with bird embeddings came from the bias computed by the projection toward he minus she vector. We retained all the vocabulary list of top 500 and top 2500 from the original experiments, which are sorted in order with bias level computed with original embeddings. We started with an assumption that words with high bias in original embeddings would also have reasonably high bias in bird embeddings, but it was found not true by examining the actual top few hundred words. To avoid this problem, we will be using new male and female bias word pool based on new bias level computed with bird embeddings.
So far, we made a replication of the paper and applied the method to contextualize embeddings. However, for the appropriate exploration of indirect gender bias in bird, we still have a long way to go. To accomplish our final goal, discovering effectiveness of debiasing method in contextual embeddings, 2 questions need to be answered. The first one is data. To calculate gender bias in the paper, just applying the cosine similarity among words was totally fine. In contrast, limited unit vocabulary in bird is insufficient to deal with gender bias. So our first plan is about the dataset. Thanks to many researchers, there are datasets for gender bias detection and measurement in contextual embeddings. We are going to look at reasonable dataset to set as criteria for evaluation of gender bias. Also, in our experiment on computing direct gender bias using BERT, we treat each word as a single sentence. However, in sentence level context, positional information really matters. So we'll consider reasonable templates for the target dataset. After we determine the method of contextualized embeddings, now we are ready to verify whether the recent debiasing methods are lipstick on a pig. Here are 3 debiasing methods in BERT, and let's take a brief look at them. First one is a sentence level extension of hard debias, which is a method for word embeddings. Hard debias evaluates bias subspace and subtracts directly from the word embeddings. This has been criticized by this lipstick on a pig paper for not resolving indirect bias. We'll see if the sentence level version has the same cons. Next, the other work proposed a fine-tuning setting that minimizes the losses about degree of bias, debiasing, and preserving useful information. Third one is quite interesting. Others of this lipstick on a pig paper have developed counterfactual data substitution, which can handle indirect bias in word embeddings. Brief idea is about data augmentation. By swapping all inherently gendered words in the copy, gender biased words became less clustered. Following this, research applied this method to sentence embeddings, but the indirect bias of this method has not been clarified yet. So we'll investigate whether this research was really effective or not. To sum up, our goal is to standardize method to explore indirect gender bias in contextual level and to verify brand new debiasing methods by using it. This was our presentation. Thank you for listening and have a good day.